Okay, so, oh, sorry. Where is my OneNote? Oh, there we go. Okay, so just the last bit of the test then. Here we have point OR is also on circle S. The length of the chord POR is 10, so that's 10 units across. The diagram shows OR1 and OR2, the two possible positions of OR. Find the possible equations of POR. So we have the kind of a very similar situation here. We still have this get the equation of the line business. So here we have a general equation of the line, and what kind of points do we have? Well, we know P. So what was P again? It was 2 minus 2, wasn't it? Yeah, 2 minus 2. So we do know what this one is, so maybe we'll fill that in. So we're going to put in our 2 minus 2 x1 y1 into this equation. So x minus 2 goes in there. So y plus 2 is equal to mx minus 2m. And I guess we'll put it all again on the one side. So mx minus y minus 2m minus 2. Now that's, I suppose, again, a kind of a general equation. And that will work for this line and also this line. So we have the line going across the way and the line going down the way. Now, what other things do we know? Well, if we think about our radius and chords, and anytime you hear chord, if a radius comes down on a chord, it splits it exactly into two. So straight away, I know that's 5 from there to there. I also know that that's a radius. And I know from the previous question and the previous calculations that that's the square root of 61. So I should be able to get x using Pythagoras' theorem. Now you might be saying, well, why do I need x? Well, of course, if I can go from the center of S, which is 7 minus 8, down to the chord, I can use the formula on top of page 19, which is me looking at the distance from a point to a line. So that's where I'm going with this. So we're going to do Pythagoras. So we're going to square, again, please write down all your formulas. I'm just kind of speeding it up a little bit. So I'm doing Pythagoras here to find out the length of x. So what's that? That's going to be 61 minus 25. And that gives me 36. So x is 6. So the distance from the center to the chord, when I say the chord, I'm talking about this general line here that we figured out. So I'm going to write down again my formula that I used in one of the other questions. So again, it's on page 19 for a reason. It is a huge connection between lines and circles. And most of the time, this is how they come up. They come up together. So what I'm saying is the distance of 7 minus 8 to this general line, and the general line is the one that's going to go in there. So this is my x1, y1. So I'm saying the distance from this general line, so b is minus 1, y1 is minus 8, minus 2m. So I don't know the m's. I don't know the slopes, basically. And again, now it's a, so that's my m squared. Remember, a is the number with x, and b, again, b is actually minus 1 squared. Now, remember, the distance from 7 minus 8 to this line is what I just figured out is 6. So I'm going to let that equals to 6. I'm going to tidy this up a little bit. So I'm going to have 7m plus 8 minus 2m minus 2. And that's going to be very similar to the last question. That's going to be 1 is equal to 6. Now I'm going to do the same thing as before. I'm going to square both sides. So it's going to be 5m when I tidy up plus 6. And I'm going to have to square that now. So I'm going to pop that as 6 over 1. So I'm going to square both sides. So essentially it means I'm going to write this bracket twice. Square root cancels with the square. So that just leaves me with that, and that becomes 36. Cross multiplying, so 25m squared, that's going to become 60m plus 36, and this is going to become 36m squared plus 36. Now the 36s are going to cancel there actually. When I bring the 30, I'm going to bring the 25 over to the 36, and I'm going to bring the 60 over, minus 60m. So that gives me 11m squared minus 60m. Now you could do the minus b on this, but because it's kind of, you know, it doesn't have the constant, I think I'm just going to take the shortcut here, but you can do the minus b if you want. M is 0 is one scenario, and the other scenario is that m is 60 over 11. So we're looking for the two possible equations. So remember, we have the y minus y1 equals m bracket x minus x1. We had the point 2 minus 2 is in both. And then, of course, one of them, m is 0, and the other is 60 over 11. So y minus y1 is equal to m x minus x1. So this one is just going to be horizontal line minus 2. Now, we could have guessed that from the diagram, actually, because if you think about it's horizontal. So look at it. If it's 2 minus 2, then it's pretty obvious that that has to be y equals minus 2. So we could have actually known that immediately. So even if you got stuck in the test, you could have done that. And then for the second part, y minus y1. So again, it's plus 2 equals. So the slope is different. Everything else is the same. Bring over the 11y plus 22. And I'm just multiplying the 60 in here. So I'm just skipping one or two steps there, but you can always pause the video and try it for yourself. So the second line is 60x minus 11y, and that's going to be minus 142. And they're my two equations, and that's done. So that's one equation, and that's the other. So one is horizontal, and basically one isn't. Very last part in the test, the x-axis is a tangent to this circle. Prove the following. Now, any mention of x-axis, y is 0. So if you imagine that we want some sort of a point on the x-axis, if you think about that point, so let's think of the circle first. So this doesn't have any numbers, so the center is just minus g minus f. So if you think of a point being a tangent to this, it's on the x-axis, so it's going to be minus g 0. Because the y part has to be 0. Now, if I get the distance from the center to this point, it should be the radius. So essentially, I'm going to label both of these as if I was getting the distance between them, x1, y1, x2, y2. The distance, again, I'm just going to skip writing the distance formula, but you guys should be writing the formulas. Plus y2 minus y1 to be squared. That's a minus there. Now, they end up becoming 0. So that leaves me with minus f minus, that's minus f squared, which is f squared. So I end up basically with the root of f squared, which is f. No, sorry. I end up with, is that right? That's f squared, the square. Actually, sorry, I won't do the square root yet. Sorry, I've just realized that I've kind of skipped a little bit of ahead there, because the other side, I'm supposed to be letting it equal to the radius. So I just kind of should have put that bit in. So the radius is g squared plus f squared plus, no, sorry, minus c. Now, so this is the situation we're in here. Now, because they both have a square root, we can drop out the square root. And then the f's cancel. And then if I rearrange, I get g squared is equal to c. And that's exactly what we were looking for.